Okay, so we've covered the SI measurement system, we've covered the US customary system, and the next logical step then is how would I convert within the system itself, so going from like meters to gigameters, and then how I would do a conversion between systems. So how do I go from the metric system to US customary? So this PowerPoint is on unit conversions, which will lead into the activity that we are going to do today. Okay. So it is necessary for science and engineering to work across different systems of measurement or express quantities in different units within a single system. We live in a global economy, and we produce cars that we ship abroad. Right? We list our fuel efficiency in miles and gallons. In other countries, they would need it in liters and kilometers. Right? So there's a need then to convert between systems. In fact, when we get to the end of this presentation, we'll look at that specific example of how we would do that. Okay? The most difficult thing with unit conversions is coming up with the proper conversion factor. The math associated with this is very simple. It's writing the proper conversion factor, so we're going to spend some time talking about that. Okay? So the conversion factor is going to be multiplied by a quantity to convert the quantity to alternative units. So the whole purpose of the conversion factor is to change the units of the number or the value. It is a ratio or fraction which the quantity in the numerator is equivalent to the quantity denominator. So what's in the numerator of my conversion factor is equal to the denominator, so that I'm not affecting the value itself, I'm just changing the units. And the desired units are in the numerator and the given units are in the denominator. Right? So this is the actual conversion factor. The value of this factor is equal to 1, and when I multiply through, my given units cancel out, and then my answer, or my remainder, is my desired units. Using a conversion factor to cancel out unwanted units is the same process as multiplying fractions. If I use this as an example, my 7s in this case will cancel out as I multiply, and I get an answer of 5 over 3. So it's the same process. The math behind unit conversions is simple. It's writing the proper conversion factor. We looked at this chart the other day when we talked about the SI system. We will use this chart to help us write our conversion factors. These are the conversion factors that we need to look at. Okay? So if I'm getting larger, let's say as an example, if I take my base unit of meter and multiply it by 10 to the first power, or 10, I'm going to get 1 decameter. If I'm using liters as the base unit and I multiply liters by 10 to the third power, or 1,000, I get kiloliters. And then finally, if I'm doing my grams times 10 to the sixth power, is going to equal to 1 megagram. It's the same thing going smaller. Okay. Yeah, I'm doing meters as my base units. I multiply meters by 10 to the negative 2 power, or I'm sliding my decimal place. I get 0.01 meters is 1 centimeter, 0.001 liters is a milliliter, and 0.00001 gram is equal to 1 microgram. So this is going to be larger than our base unit. These ones are going to be smaller than our base units. Okay? These are also all powers of 10. Prefixes are powers of 10. And so we are sliding our decimal to the left or to the right to make the conversion factor, which is really nice because it doesn't change the value or the number. It's just we're sliding decimal places. The numbers stay the same and our units will change. So let's do an example where we want to convert from, we're going to go from grams to micrograms, and we're using our chart as the example. If I were to write it as an equivalency, meaning this is equal to this, using this chart, 10 to the negative 6 grams is equal to 1 and then microgram. This equivalency then can be written as a conversion factor. 1 microgram divided by 10 to the negative 6 grams. And that would be the conversion factor I would use to convert from grams to micrograms. Okay. Desired units are in my numerator, given units in the denominator. This is our equivalency. This is the actual conversion factor, and it is equal to 1. One more example using this here. I want to convert from megameters to meters. So as an equivalency, 10 to the 6 meters, this is coming right off of this chart, is equal to 1 megameter, or I can write the conversion factor 10 to the 6 meters divided by 1 megameter. And this is my equivalency. This is equal to 1, and is my conversion factor. Okay, let's do an actual example then. As our example, we want to convert 103.2 centimeters to meters. Okay. So my given units currently are centimeters. My desired units, or what I want to convert to, are meters. So I write my conversion factor. Right? Desired units, I want to go to meters. I'm currently in centimeters. Using the chart, I know that 10 to the 2 meters is equal to 1 centimeter. So I have to make this conversion factor equal to 1. And I do that by adding the numbers here. When I multiply through, my centimeters will cancel out. 10 to the negative 2 is the same thing as sliding the decimal places to my left 2 times. And I get 1.032 meters as my answer. This is showing me sliding the decimal based on my powers of 10 to get to the answer that we came to here. Let's talk about rule of exponents. So this comes in handy, especially when we're talking about the SI system, using that chart and doing our conversions. Anything, any number, no matter what the base, times an exponent of 0, or to the exponent of 0, is going to be equal to 1. Okay, so if I look at an example, 1.032 times 10 to the 0 power meters is the same thing as multiplying this number by 1, and I get the answer here. Okay. If I have numbers that I'm multiplying the same base and they have different exponents, multiplying those is the same thing as adding the exponents together. So 10 to the n power times 10 to the n is the same thing as 10 to the n plus n. So 10 to the 5th times 10 to the negative 2 is 10 to the 5th plus a negative 2, and I get 10 to the 3rd power. If I'm dividing numbers that have the same base and different exponents, 10 to the m divided by n is going to be 10 to the m minus n. And as an actual example here, 10 to the 6th power minus a negative. I'm subtracting a negative, so I will be distributing this negative, which ends up making it a positive number. So I get 10 to the 7th power as the remainder for that. And the reason we're covering this is to, when we do the next couple examples, we can use these rule of exponents to make the conversion process a little bit simpler. So if I'm converting 0.005 kilometers to centimeters, notice that there are 2 conversion factors. I'm going from kilometers to meters first, and then from meters to centimeters. My kilometers are going to cancel out. My meters are going to cancel out, and what I'm going to have left is 0.005 times 10 to the 3rd divided by 10 to the negative 2, which, using my rule of exponents, if I'm subtracting a negative, I'm basically adding 2, and I get 10 to the 5th. This tells me to slide the decimal to my right 5 places. And when I do that, I get an answer of 500 centimeters. So we can use the rule of exponents to simplify the process in examples like this. Here's another example, similar. Going from hectoliters to megaliters. I'm using 2 conversion factors, which is like dimensional analysis, and we'll talk about this a little bit later in the PowerPoint. These units are going to cancel out. My liters are canceling out. 10 to the 2 divided by 10 to the 6 is 10 to the negative 4. I'm going to slide my decimal to the left 4 times based on powers of 10, and I get a conversion factor, or I'm sorry, a conversion of 0.051967. Now we do have to mention precision when we talk about this and significant digits. The number of significant digits going in, ideally, is the number of significant digits coming back out. Right? That's technically the right way to do that. Measurements are often recorded to incorrect precision, and alternatively, when we convert measurements, are often rounded to a given number of decimal places. In our example, it's not critical, so we can just leave, if we end up with more digits after the fact or significant digits is long, we'll leave that. It's not critical, but technically, the number of significants going in and coming out would be the same. All right, so let's talk about the US system now. We did conversion in SI, which is really simple because it's based On powers of 10, I can slide the decimal one way or slide the other way to do the conversion. When we do the US system, you actually have to know what the conversion factor is. And you do probably most of them, right? Most of you know that if I'm converting from feet to inches, I know that 1 foot is equal to 12 inches. And I can write my conversion factor 12 inches over a foot. Again, desired units are in my numerator, given units in the denominator. Some of you probably know too that miles to feet is a conversion. 1 mile is 5,280 feet. So again, that can be written as our conversion factor. In both cases, they're equal to 1. So then we multiply by number. It's not changing the value, it's just changing the units. So let's do an example then. I'm converting 7.2 yards to feet. So I'm writing my conversion factor. Given units is currently yards. My desired units is feet. So I'm going to put feet in my conversion factor in the numerator and yards in the denominator. I know that there's 3 feet to every yard to make this equal to 1. I multiply through, my yards cancel out. This time though, I can't just slide the decimal place. Right? I have to actually multiply the 3 by the 17.2. When I do that, the value is no longer just sliding decimal place, so I get 51.6 feet. So just like in the metric system, we have to write the conversion factor, and that's probably the trickiest part of the process. Let's do a couple more examples using feet and inches. I want to convert 3 feet, 7 3/4 inches. So this is 3 feet and 7 3/4, not 3 feet minus 7 3/4 inches. I'm going to convert this to inches. 7 3/4 is already in inches, so I don't have to convert that. I simply have to convert my 3 feet. So I'm going to write a conversion factor for that. 3 feet times 12 inches over 1 foot. Feet cancel out. 3 times 12 inches plus my original 7 3/4, I get 43 3/4 inches. Similarly, I can do a conversion where I'm converting feet and inches to just feet, or decimal feet. So I have to convert the 7 3/4 inches to feet. It's going to be in a decimal format. I'll write the conversion factor. My inches are going to cancel out. So I get 7 3/4 divided by 12, which is 0.65 feet. I add the original 3 feet. I get 3.65 feet as the conversion factor. All right, so now let's talk about converting between two systems. Okay, if I want to go from the SI to US customary or vice versa, we need to know the equivalency, and we have a bunch of charts and diagrams on our formula sheet, which I'll show you where that is on the LMS in a second. But you don't necessarily have to memorize these. We would pull these directly from a chart, right? So 1 inch is going to be equal to 2.54 centimeters. If you don't have that memorized, you just pull that information from the chart. Nothing changes though, even if we're converting between units. Desired units on top, given units on the bottom, must be equal to 1. That is the conversion factor. So let's do some examples then. 34.7 inches, I want to convert that to centimeters. I write my conversion factor. This comes right from the chart, 2.54 centimeters over 1 inch. This is equal to 1. My inches will cancel out. I'll multiply through, and I get 88.1 centimeters. Let's do another one. Convert 17 kilograms to pounds. Using my chart, 1 kilogram is 2.205 pounds. My conversion factor, the kilograms will cancel out. I multiply the 17 through, I get 37.48 pounds. All right, last thing we want to talk about then is dimensional analysis. And we did examples similar already where we have 2 conversion factors to do our conversion. The units appear in both the numerator and denominator in this case in order for all the units to cancel out. So if I have, let's say, given units times our linking units over given units times desired units over linking units, when I multiply through, my given units will cancel out, the linking units will cancel out, and my answer then is desired units. That's kind of the remainder for the process. So let's do an example. This is a very simple example. If I want to go from inches to yards, I'm going to have linking units, and I'm going to have those be feet. Right, so I'll go from inches to feet, and then convert from feet to yards. So 345.7 inches. Here's my first conversion factor. It's going to convert this to feet. My inches are canceling out. I'm multiplying through. Here's the second conversion factor to cancel out the feet, so that my answer is in yards. I get 9.602 yards. So in this case, I'm using two conversion factors with linking units to go from inches to yards. Now, we could write a conversion factor that would go directly from inches to yards, right? It could be a conversion factor of 1 yard is to 36 inches. But in this case, as an example, we're showing you the linking units. All right, here's our last example. And this is what we started the PowerPoint talking about. I am an American car company, and I've designed a very high fuel efficiency vehicle that's rated at 55 miles per gallon. Now, I want to export this. I want to sell this abroad, but I can't advertise the fuel efficiency in miles and in gallons because they're not going to be familiar with what that means. So we are going to convert that to kilometers per liter. So I have to remove or get rid of my miles and gallons. And so there's going to need to be two conversion factors, 55 miles per gallon, and we want to go to kilometers per liter. So let's focus on the gallons first. 1 liter is 0.264 gallons. And this comes off of a chart. I don't expect anybody to memorize this. I'll write my conversion factor. My gallons are going to cancel out. I'll write a second conversion factor to go from kilometers to miles. 1 kilometer over 0.621 miles. Miles are going to cancel out. And when I multiply through, I'm going to answer 23.4 kilometers per liter. I would probably round that to a whole number to advertise the car as 23 kilometers per liter. So let's talk about today's today's activity based on this PowerPoint. We're starting unit conversions today, 3.2. There's two ways to go about this. You can work directly on the Word document if you want to type into the Word document. For some of you to show the work, you may find it easier to do it in the notebook. So if you want to write out your work in the notebook, we can. But we're going to work through a bunch of problems where you're going to be using conversion factors to convert from whatever the given units are to what the desired units are. Okay? There is a formula sheet for you guys to use on this. I actually loaded it in the activity itself. So if you go to 3.2 unit conversions, there's resources and you can pull up the formula sheet. And on the formula sheet, we want the third page. The third page has all of the conversions on it between systems, and then our prefixes or powers of 10 that you can use for this activity. So no matter which way you choose to go about this, whether you're doing the work directly on the Word document or you're choosing to do it in the notebook, please make sure that you're showing the work. I need to see the conversion factor that you're coming up with, because that's typically where the mistakes happen. And if you're just giving me an answer, I'm not seeing kind of the process. So whether you're typing it in or you're doing it in the notebook, please show the work. So we're going to work through these. Some of them are like word problems. And then some of them are pretty straightforward, not necessarily word problems. There is a couple conclusion questions too at the end that I want you to do as well. And when you finish this, please submit everything to the LMS for 3.2.